Hello.
Hi.
My friend told me that there is a really interesting sport event taking place next month, so I want to book a ticket.
Yes, yeah, a lot of exciting events coming up. So which one are you interested in?
It's a football match at the National Stadium.
Football?
Yes.
So yeah, I have found it is the football championship finals.
Yes.
So it will take place in the June 15 at 6 p.m. So yeah, still 5,000 seats, 10,000 seats available. So yeah.
Yeah, that is really great. Book me a ticket.
Okay. So which type of seat are you interested in? VIP, premium, or standard?
Premium, please.
Okay. So and how many tickets do you want to buy?
Two. Me and my husband.
Okay. So do you want to choose the seat position?
I think A4 in A5 is suitable.
Okay. So may I have your information, please? So can I have your name, please?
My hat, please.
Okay. So can I have your phone number?
0 1 2 3 4.
Okay. So your email, please.
abc.com.
Okay. And finally is the address.
I live in La Hà Đông, Hà Nội.
Okay. So you have two premium tickets. The total bill is $2,200. So which payment method do you want to use, please?
I want to pay by cash.
Okay.
My money.
Thank you. So please check your final tickets in here. So you have two premium tickets that seat A4 and A5 in the football championship finals, which will take place on June 15 at 6 p.m. And you are my hand. The phone number is 12344, and the email is abc.com. And you live in La Hà Đông, Hà Nội. And your booking ID is 8. Is this right?
Okay, thank you.
Okay, so here's your ticket. Thanks for booking.
Excuse me, I have booked 2 tickets, but now I'm busy that day, so I want to consult.
So please provide me your ticket ID, please. Your booking ID.
It's 8.
Okay, I have found it. So you have paid $200 for this seat for the 2 premium tickets. Is that right?
Yes.
Okay. So your name is Maihan. Your phone number is 102101234. So here's your refund.
Okay, thank you.
Yeah, see you next time.
Goodbye. Okay.
All right, you have just seen a small part in our project, the spot ticketing management system. And there are many other interests. It supports multiple stakeholders, including the cashier, manager, system administrators, and event organizers by automating tasks such as event creation, seat management, booking, cancellation, and reporting. The system ensures accuracy, efficiency, and security, offering a convenient access to event and sales data, supports future expansion, and provide valuable insights for informed decision-making while enhancing the customer experience at the stadium box office. To be more specific, we will see the functional requirement, which are the core features that the system needs to perform. They include event management, ticket management, and seating management, which allow the event organizers to create events, define ticket types and pricing, and manage the seat configuration. The seat availability, booking, cancellation, and customer management are handled mostly by the cashier, enabling the real-time tracking, booking, updating the seat status, and storing customer data. Concurrent sale and double booking control have to ensure the smooth operation when tickets are sold simultaneously at multiple box office and prevent the errors like double booking. The interface feature provides a user-friendly user interface for daily casual tasks and reporting, which is used by the managers, has to generate the insights and export the ticketing statistics. Finally, the user management, which belong to the system administrators to manage roles, permissions, and user accounts. So next, we will have some non-functional requirement for the sport ticketing management system, focusing on system performance. So the response time. The system must ensure the quick booking during even peak times, and transactional throughput mean the system guarantees the system itself to handle the multiple transactions per second. Role-based access is repeated multiple times to emphasize that only authorized user can access specific features, ensuring the proper security. That data protection ensure the customer contact information is encrypted, maintaining privacy. And finally, the gold standard is to ensure the system is maintainable and secure, following the best practice for future updates. Those requirements ensure a fast, secure, and reliable system for all users. We come to the part of system analysis, starting with the event setup, followed with ticket booking and cancellation process, and ending with sales reporting and analysis. So, to the part of sport event management process, it starts when the event organizer want to organize the new sport events, and they enter the key event details like name, description, venue, time, and define the ticket types like VIP or standard, and assign price to each. Next, they configure the seating layout by assigning seat numbers and types, linking them to the ticket categories. Ultimately, the event is published and visible to the cashier for booking. Exactly, the ticket booking process is that when a customer comes to the stadium box office and asks for a ticket, then the cashier gathers event details and search it on the system. If not found, the customer is asked to revise the information. But if it found, cashier will check the seat availability. If sold out, the customer is informed. But if seats and in case the seats are available, so options are presented for customer to select, then the cashier will process the payment. Upon the payment, the ticket is issued via print or email, then sent to the customer, and then the transaction is completed. In case customer want to cancel the ticket, so they also comes to the stadium box office and request to cancel. The cashier will collect the ticket details and searches for the booking on the system. If not found, the process ends with no cancellation, as it's no booking. If found, the cashier cancel the tickets and process the refund, send it back to the customer, and the cancellation completed. To the purpose of report the revenue. So the manager logs in, navigates to the reporting module, and select report criteria. Then the system will automatically show the results. Then manager can export the report, and the revenue report is completed. Now, let's have a closer look at the part of database design and implementation. As you can see here, the system is structured around 6 key tables: events, tickets, customer, box office, seats, and ticket sale. Each table serves a distinct role while maintaining a tight relational links. Like the events table stores event information, including name, date, time, venue, description, and available seats, and acts as a parent to both tickets and seats. Ticket types and pricing tiers are managed in the tickets table, linked back to the specific event. Customer information, including name, phone number, address, and email, is stored in the customer table, which connect to the transaction hub, ticket sale. The ticket sale table logs all transactions, integrating foreign keys from tickets, customer, box office, and seats, while also capturing metadata like sale date, total amount, payment method, and status. Two supporting tables include the box office and seats. Box office define the name, location, phone number, and opening hours of each box office, and seats used for checking individual seat allocation, status, and pricing modifier.
Okay, so the next section, the advanced database objects, will be presented by me, Huỳnh. In this section, we will explore 5 advanced database objects, which are indexes, views, store procedures, user-defined functions, and triggers as well. And all of these advanced database objects play a really important role in optimizing performance, automating operations, and ensuring data consistency within our event management system. Okay, so first one, the index. This is used to speed up queries, which work like a table of content, help you to find data faster. So without the index, the system has to scan the whole table, which gets slower as the data grows. So for example, here in our seats table, we created an index called the index seats availability on the event ID and the is reserved columns. This helps quickly find available seats for a specific event. And when we use the explain statement, this will include the useful information like the select type, the possible keys, the type of table, and these details will help you to analyze how efficiently the query will run, whether the index are being used or if full table scans are happening. And on the other hand, when we want to retrieve the real data from the database, the query is written without the explain. So it will start with the select seat number from seats, where, for example, we have the seat event ID is equal to 1. So we have a table of seat numbers here as we run the queries without the explain. And the next one, the second one, is the view. You use this to simplify the complex queries. It works like a virtual table since it doesn't store data itself, but it shows a result from queries. So for example, here we have the view revenue by event. We created a view revenue by event by joining the events table, the tickets table, and the ticket sales table to calculate the total earning and the ticket sold for each event. And this will help the finance team to track the revenue. And what we run here when we select all from view revenue by event, we had the event ID 1 with the event name is Football Championship Finals, and the total revenue was 1,500, and the total ticket sold was 14. And the third one, store procedures, is used to simplify the automate complex tasks and keep the process consistent. For example, we had created a book ticket procedure here. What we did here is the first one, this procedure, we insert into the ticket sales to record the sale in the ticket sales table. And then when we update the tickets, we set availability equal available -1, where ticket ID equals p tickets ID, which means that it decreased the available ticket count in the tickets table. And lastly, we will mark the selected seat as reserved in the seats table when we update seats with the set in reserve equal true. And after that, when we call the book ticket procedure, it will automatically book a VIP, for example, a VIP ticket for customer 1, reserve 1, seats 1, and process a 150 credit card payments, and all will happen in just one step. And the fourth database object is the user-defined function. It's used to calculate values instantly and support the event analysis. For example, here we have the total revenue by event function. So we create this function, and when we apply it, we can just select total revenue by event, and the event ID is 1 as revenue, so that we can have the number, the revenue of it is 1,300. So this helped a lot in saving the time and improving the decision making for the event managers. And last but not least, we have the triggers one. It is used to ensure the accurate and real-time seat availability. So a trigger is an automated action that runs when certain database events occur, like inserting data, updating data, or deleting data. And for instance, here we have a trigger of updating seat status after insert, which means that it will update the data after a seat reservation. So if the sale is marked as confirmed, the trigger will automatically update the related seats in the seats table, setting its reserved is equal true. And it would happen the same if there is a deleting data or updating data, and so on. So that's the end of advanced database objects. And the next part will be presented by my teammates.
So next, I will present about the Python application development. So in this part, we will talk about 5 things: is the application architecture, database connection, booking system, reporting module, and user interface. First, talk about the application architecture. We use the 3-type architecture in Spring MVC, which is view, controller, and model. So first is the presentation layer, which is view, which handle user interface interaction. Second is the business logic layer, which is controller. This will manage section, routine, and form submission. Finally is the data access layer, which is model. This will interact directly with the relational database and handle queries, booking contracts, or purchase history. The next part is main model. So the system is divided into a number of high-level functions model, which including 5 parts. The first is the database manage module, which will handle all interaction with the MySQL database. Second is the booking module. This will manage the creation, retrieve, and cancellation of event bookings. Third is the refund model. This will calculate refund amount based on the ticket price and the quantity and update to the database. The fourth is the event and ticket manage module, which retrieve event data and display corrupting ticket options. Finally is the UI model, which helps the system to build the framework. So moving to the data flow and processing. So data flow within the system is event-driven and follows a well-defined pipeline from user interaction to data presentation. The canon pattern observed throughout the application can be expressed as 4 parts, which include the user action incitation. The system operations start from user actions and captured and handled through the common bindings. Next is the data query execution. The functions build parallel SQL query to securely interact with MySQL. Next is the business logic computation. After the data retrieval, the Python handle business logic, availability, and computing price and enforcing rule like status checks. And lastly is the user interface update and feedback based on the refreshing data using widget, like top level, label, or tree view. The next part, I will show some code and then explain it. The database connection management, which include the system use a DB management class to manage MySQL connection, initialize one and share across module. And this object-oriented design supports code to reusable and reassure a clear separation of concerns. Next is the transaction and query handling. So the DB management class encapsulates the logic for connecting a MySQL database using MySQL.connector. So a dictionary crucial, which is true, is used and allowing query result to be accessed via column names instead of indices. So it will include key methods, including the executed, which run the SQL query, the fetch button, which retrieve query result, commit, which commits change for operations like insert, update, and or delete. Next is the error and exception handling. So the purpose of this part is to ensure system stability and data consistency during real-time operations, for example, like ticket booking or cancellation. So the implementation, which is use try except blocks around a critical database interaction. So the benefit of this is that they can prevent the system crash, provide user-friendly error message, and maintain fault tolerant and data integrity. Next will be the booking system. So the first module is the event and seat search, so that user can search events by name, date, or venue. So in the real-time availability using choice between event tickets and booking table. And finally, the comprehensive ticket into fetch per booking, including customer detail. The second module is the ticket booking process. So this is how the system handles ticket in inventory. Applying inverse logic is used when booking. So the booking workflow is that the user will check the availability, insert booking record, update available ticket count, and commit transaction to maintain consistency. And this will prevent overbooking by enforcing data check. The third module, which is cancellation and refunds. So user can select a booking to cancel, system check if already canceled on, and finally is all change handled within a transaction. So on confirmation that you will update booking status to cancel, restore ticket quantity, and then calculate the refund money. Next is the reporting. So this part will be revenue statistics. So it will be calculated as price multiplied by quantity, excluding cancel booking. So this is basic for the revenue per booking and grouped report. Also, it can use for ticket sale report, which track the total ticket sold per event, popular ticket type, and sale trend over time. So this data include event information, customer information, ticket type, and booking status. Lastly, it will be the real-time dashboard. So the current UI support basic live update, which including booking list refresh after cancellation, building vertical dynamically reflect database change. Lastly is the user interface. So the user interface design, which our group choose the UI. So UI-based design shows over the console for better usability, especially for non-technical user. So the model interface with layered navigation, which including main menu, booking view, cancellation window, etc. The design feature, which including the label, the theme widget, including the label, button, preview, etc. The global style, which including color and font for constant UI. And lastly, the address to a usability principle, which clarity, consistency, or error prevention, and is suitable for the development in real-world ticket system. So this part we already have in the first presentation, and that is the end of my presentation.
I will present Section 5, Database Security and Administrations. This section is crucial to ensure that the system runs safely, consistently, and efficiently. First, user management and access control. We first define different user roles. Admin can manage the whole system, user permission and everything. Event organizer handle event creation, tickets and seating. Cashier process bookings and customer data. Manager view response and statistics. Will create user to create accounts. Range to give specific asset. Revoke to remove permission. So range to check what each user can do. This role by asset limit risk and keep the system secure. About data security, we encrypt sensitive data like phone number and email using MySQL AES function. AES encrypts store data in unreadable formats. AES decrypt restore it when needed. Set the encryption key. We also convert column type to binary to support encrypt value. This ensures customer data remain private even if the database is accessed without permission. Secure transaction handling. Ticket booking involve multiple steps, seat reservation, ticket update, and sale recording almost success together. We use start transaction to begin overlaps, update and insert to apply change, commit to confirm if everything success, rolls back to under change if anything fails. This keeps the database consistent, no pressure update, and no corrupt data. About backup and recovery, to protect against data loss, we implement a backup plan. MySQL dump exports the database to a SQL file. MySQL restore it during system failure. If the database is deleted, we will create database to rebuy it. This ensures that we can fully restore the system at any time. Or performance optimization, we use exclaim command to find slow query and eliminate full table scan. After defining bottlenecks, we add index line, create index on ticket ID, customer ID, and service. This change query type from overflow scan to breadth index break, reduce scans row from 1,000 to 0 few. Results, faster query, better scalability under high traffic. Let me now wrap up with our conclusion and recommendation. The support ticket management system was successfully developed as a production-ready solution, surpassing an initial expectation. It achieved a 92% overall test pass rate with 100% success in all critical areas, including secure booking, real-time sys management, and comprehensive reporting. Performance benchmark shows sharp second response time and support for 150 concurrent users. Our MySQL architects enhanced with index trigger and store procedures ensure optimized speed and data integrity. We also implement AES encryption and rules-based asset control for enterprise-grade security. To stay competitive, we recommend several enhancements. First, integrate QR code scanning for faster contactless checking. Second, support online payment via stripper or PayPay to execute sales. Third, develop a mobile app for managing tickets and event reminder. Additionally, features like social media integration, real-time dashboard, loyalty program, and multiple language support will further boost customer engagement. In short, this system transforms manual ticket into modern, scalable solution ready to grow with user needs and market demand. Thank you.